Okay, so recording 2016, number 3, for your response is the light blue packet. And we're going to go over an FTC style problem. So here you have the graph of f, and also told that g of x is a definite integral with lower limit of 2, upper limit of x, and you're integrating f of t dt. And remember, the input variable used, like t or x, is totally arbitrary. The bottom line is that g of x is the integral of f. So what this means is that we need to quickly establish, they do look for this, somewhere in your paper that might say they have the AP graders. You quickly want to say g prime equals f. That's FTC part 1. And also, we might need to say that too, that g dou prime equals f prime. So it means that the derivative of g just represents y values. So the derivative of g are just y values on the graph of f. Excuse me. On the graph of f. This means that the second derivative of g are just the slopes of tangent lines on graph of f. So that is kind of the whole basis for doing these problems. Excuse me, I'm still shaking a cold here. Okay, so first question, does g have a relative minimum, relative maximum, or neither x equals 10? Okay, at x equals 10, so they're asking for g prime. Okay, and remember, to be a relative minimum, g prime must be going from negative to positive. To have a relative maximum, g prime must be going from positive to negative, and neither, then you don't see a sign change at all. No sign change for g prime, because remember, we're talking about extremes for g, so we have to look at g prime. Well, remember, g prime equals f, so the derivative of g are just the y values on the graph of f. So, for example, any y value here on this graph represents a derivative for g. Well, here's the thing. F is negative before you get 10. F is negative after 10. It never changes sign. If f doesn't change sign, g prime doesn't change sign. Therefore, the answer for A is neither. Now, when I ask you to justify, here's what you want to say. So this is probably, my guess is probably worth 2 points. 1 point for saying the right thing, 1 point for the justification. Excuse me. So what you want to say is this. Neither, because g prime or f does not change sign at x equals 10. That would be your justification. And that's all you really need to say for that one. Now, for B, does G have a point of inflection? Now, point of inflection is when G dou prime changes sign, right? So you can see section 5.3, which was a long time ago. That was when we did first derivative test, concavity, all that stuff. That was so important. That's the reason why I did it so close to section 6.4, because you had to see that, section 6.4 is FTC, so you had to kind of see those connections. And so because of the shortened schedule we had, I had to be very decisive, and that's why I kind of decided to do things that way, because this is such an important part of the course. So G dou prime has to change sign. So that means that f prime has to change sign. Well, f prime is the slope of a tangent line. So you need the slopes of the tangent lines on the graph of f to change sign. At x equals 4, that definitely happens, because the f prime here is positive, because that's a positive slope. F prime here is negative, it's a negative slope. So the answer is yes. And how do you justify it? Here's what we say. Yes, because G double prime or F prime changes sign at x equals 4. And that's your justification for that one. So there's not really much you have to say. And again, I'm guessing that's probably also worth 2 points because one for saying yes or no correctly and one for the reason. In fact, let's actually take a quick little check of the solution key, which you guys already have in Schoology. Okay, let me clear my screen. So actually B was only worth 1 point, but you can see here I was correct. Well, I guess they gave 1 point for at least making that statement anywhere along the way. So, okay, so you have a point for the G prime equals F thing. So we took care of that right from the get-go. Then I guess there's 1 point for the answer with just, so if you gave the answer but no justification, then of course you're not gonna get that point. And right, they say that since G prime equals F and F of X, yeah, I mean that works. If you said no sign change, they would give you credit for that too. Then here, and again, we already said G prime equals F, so we don't have to have an exact answer, but they said that G prime is increasing and then decreasing. That works, or you could say F prime is positive or negative because it's the same thing. Remember, when you're saying a rate, a derivative is increasing, that is actually a second derivative. So they would accept that as well. So it doesn't have to be exactly like this, just so you know. Okay, so now let's look at part C. Find the absolute minimum x. This is extreme value theorem. They love this. I'd be shocked if you don't see this at least once or twice in the free response. Remember, extreme value theorem means you need to have endpoints, you need a test, test endpoints and critical points. Also, must be continuous on a closed interval. I would actually state that somewhere along the way because they might want to look for that as a criteria for giving you points. Are we closed? Absolutely, right? -4 and 12 are included. Are we continuous for G? Well, we would have to be because G prime equals F, right? Is F continuous from -4 to 12? Sure, look at it. F is totally continuous. So that means that G prime exists everywhere. So it means that G prime is differentiable from -4 to 12. Well, if you're differentiable from -4 to 12, you're continuous from -4 to 12. If you're differentiable, you're continuous. So you can maybe make a statement about that too. And here's how you could write it. You could write it like this. G prime equals F, and F is continuous on closed interval from -4 to 12. That means that G is differentiable on that same interval. That also means that G is continuous on that interval, since differentiability implies continuity. So this is a theory that comes into it, right? This is what they're after. This is when you've achieved full mastery of this course, when you can fully have a command of this. G prime equals F, duh, we said that already. Of course, F is continuous in the closed interval from -4 to 12, duh, look at the graph. So therefore, G is differentiable, right? Because we established that G prime equals F. If F is continuous, therefore G prime is continuous, meaning that G is differentiable on that interval. And if you're differentiable, then you're also going to be continuous, because we talked about that from the first unit back in the fall. It might help to add that, because it probably, I mean, not saying this stuff is subjective, but it does give the grader a little bit more empathy for you if you happen to maybe make a careless mistake somewhere along. I mean, not saying they'll give you credit, but if there's anything that's debatable, they might lean towards giving the point. So, just the more theory you could show, the better, if you can. Now let's actually do it, right? So what are our endpoints? -4, and 12, okay, are endpoints. The critical point is when g prime equals 0 or does not exist, but because we're differential everywhere, we don't have to worry about g prime not existing. Or f equals 0, right? Because remember g prime is f. So where's f equals 0? 1, 2, 3, 4. A lot of different places here where that happens, okay. So we're gonna have to test those out. So I'm gonna have to expand my table a little bit. So -2, 2, 6, and 10. Okay. Now, we need to establish which one is the highest and the lowest. Okay, well, if you integrate from 2 to 2, that's 0. So I know that's 0. Fortunately, these are just a bunch of triangles, so it won't be too bad to find these values. If you integrate from 2 to -2, you're going backwards. So we see here the base is 4. The height is also 4. So the area is 8, but it's going backwards, so it's -8. If you integrate from 2 to 6, that's also 8. It's going forward, so that's 8. If you integrate from 2 to 10, you're going to have both these regions cancel, so that's 0. So it's not too bad. Even though I was a little hesitant, like, oh my God, we have 6 points we have to test. If you integrate from 2 to -4, again, you're going backwards. So this is -8 because it's above the x-axis, going from right to left. That's going to be -4 here because the base is 2, height's 4, but it's going backwards. So so it's a double negative. So that's going to be 4. So together that becomes -4. That was a little tricky. And then finally, if you go from 2 to 12, remember these cancel out. And then you have this region, which is below the x-axis, and going from left to right, we keep that negative. So that's -4. So our absolute minimum, and it said find the absolute minimum, not the x values there, just find the absolute minimum. So you could say, how do we write the justification here? Okay, so you say abs min of -8. I'll say the x value that goes at x equals -2. And abs max of 8 at x equals 2. Sorry, x equals 6.
Mr. E.
Yeah, go ahead.
I don't why do you get the integrals from the respective x equals 2?
Oh, great question. I glossed over that because that's part of the integral right here.
Oh, okay.
That's how G is defined. Yeah, sorry, I glossed over that. Yeah, that's what we started at too. Right. I should have been a little more clear about that. So let's look at the answer key. See, just to make sure I hit all the marks. So that's worth 4 points. That's a bulk of the problem here. So definitely, I was correct in my absolute maximum. And that's a statement you make. Hey, we have absolute min here, absolute max there. That's fine. 1 point for considering -4 and 12 endpoints, which I did do. 1 point for considering -2 and 6, which were critical points. I guess I didn't have to consider 2 and 10 because you didn't see a sign change because they weren't relative mins or maxes. So it was actually redundant of me to do that. I didn't have to do 2 and 10, but we did see a sign change because f changes sign, meaning g prime changes sign at -2 and 6. So a point for considering the critical points, a point for considering the endpoints, and then 2 points for the answer justification. So 2 points for saying the absolute min correctly. Sorry, 1 point for saying absolute min correctly, 1 point for saying absolute max correctly. Then lastly, excuse me, let's look at D, and I'll have you guys try one on your own. From -4 to 12, find all integrals where g of x is less than 0. So that's really just looking at, that's going to be really more by inspection, I believe, because g of x is an integral, right? From 2 to x. So where will this be less than or equal to 0? Definitely at 2, it equals 0. And as I go forward, I'm just accumulating positive area. Now, so I have negative area here, but then, of course, and I do get negative area after that because I'm accumulating more negative area. So I would say definitely from 10 to 12, Now keep it close, because definitely at x equals 10, it's exactly 0. And x equals 12, it's totally negative. I also would say from 2, because you're accumulating negative area this way, that's above. And of course, you're still accumulating, well, the area gets getting more positive, but it's still going to be negative when you get to -4. So I'd say from -4 to 2. I think you just state the intervals. They didn't really ask for justification. So I think you've been fine for just giving the intervals. And that'd been fine. And you can put it like, in inequality notation or interval notation, totally up to you. They'll accept either one. And I don't think you really had to, I mean, you could maybe make a statement about the area accumulation, maybe type, write some words out like, well, we know that, the integral from here to here, from 2 to 6 is positive, and from 6 to 10, it counteracts the one from 2 to 6. Then after that, we have the negative area. That might help a little bit. But I think the intervals have been fine for that one. Okay. So now I'll have you guys try 2017, number 3. It's very, very similar. Here you have a semicircle, you got a couple triangles. They do tell you f of -2 equals 7. Now here, they give you the graph of f prime. So they don't really use different letters, but it's kind of the same thing in some ways. It's not that much different. Because, really, if you think about it, this right here, instead of saying graph of f, it's really the graph of g prime, right? So because f was g prime. So don't worry. It's still pretty much saying the same thing. Now they do give you f -2 equals 7. So what you're going to probably want to wind up doing, just so you know, is you're going to probably want to set up an integral. Just so you don't get confused. You're going to want to establish that and just say that equals f of x minus f of 2. That's going to help you tremendously with this problem. Because if you don't really see that, you're kind of hosed. I'll tell you right now. So but it's still the same thing that we talked about before. Just they did it a little differently. They didn't do 2 different letters, but it's still the same thing because it's FTC part 1. So anyway, go and try 2017 number 3. I'll give you guys say 9-10. We'll check in to see how it's going, and then we'll do another problem type. And I'll just stand by here. I'm just gonna do some other work here. But why don't you guys try that? If you have questions, just ask, type in the chat, and I'll stop the recording so I don't waste memory here. Okay. So I'm resuming the recording, doing 2016 number 5. So number 5, they give you a funnel. Looks weird. It's not a cone, by the way. Don't think it's a cone. It's a funnel. And apparently the radius is a function of the height. So the radius changes based upon the whatever changes see with age in that fashion, with that relationship, that equation there. They do say that the inside of a funnel has the total height is 10. You know that. So if we went from here to here, that whole thing is 10. So asked to find, first of all, they want the average value of the radius. Remember, average value is just an integral, right? And you're going from 0 to 10, so you're doing 1 over 10 minus 0 of the formula for radius. You're going from 0 to 10. And you just integrate that. I'd probably move the 1/20th off to the left, so make it 1 over 200. And then start doing my, definite integral business, right? So at 1/200th on the outside. Let me move this over here. So that's going to be, I don't know why I put that much space. That was weird. 3h plus h cubed over 3. And of course, you're going from 0 to 10. Yeah, I didn't need that much space. So it's 1/200th. If you plug in 0, they're all going to go away. But if you plug in 10, you get 30 plus 1,000 over 3. and of course minus 0. And you can leave your answer like that, actually, just so you know. But do state the units, please. You will not get a point for the units. And so this is just inches. And you actually would be fine at that point. You don't need to simplify it any more than that. If you did feel so compelled to do that, then of course that'd be 90 over 3 when you find the LCD. So you get 1090 over 3, and then of course you have 1 over 200. I guess you could cancel some 10s there. So you get 109 out of 60. So I guess you could do that if you wanted to. It's not necessary, just so you know. And you can see the answer key for 2016. Number 5, yeah, they get 109 out of 60 right there. But they would have, if you left it like this, you would receive full credit. But state the units though, state inches, very important. You'll lose that point, which would really suck to lose that point. 1 point for the integral, setting it up correctly, 1 point for doing the antiderivative, and then 1 point for the answer. So that's 3-point problem right there. Now, the next one's a little confusing. They're asking you to find the volume. So it's totally a revolution type problem. What I would do is I would actually put this on a coordinate plane like this, where I'm going to make the end of the funnel the origin. So that's the origin right here. And you have a curve, right? Let's assume that this is just a curve that you're given. And it's like a parabola. Think of it like that, okay? And you're taking that portion of that curve and rotating about the y-axis. So, and think of r being like x. And this is the h-axis, and think of that like y. So really it's like saying x equals 1/20th 3 plus y squared. If you actually were to graph that, you'll get a sideways parabola that you see in red. That was the tricky part to this problem, is being able to model it on an xy coordinate plane, because that way it's more tangible. Then you can actually use the techniques you've learned about volume revolution. Well, it's a disk method. This is what's happening here. So you're having these disks being rotated like that. The radius of the disk is simply going to be the difference in these x coordinates. The x coordinate on the y-axis is 0. The x coordinate here is dictated by that function. So, and duh, of course our radius is 1/20th 3 plus h squared. We know that. When you do volume revolution, you put pi on the outside, and because we're going, vertically from bottom to top, we're stacking these disks. We're going from 0 to 10, right? You want volume of the whole funnel. 0 to 10 of your radius squared, which is obviously dictated by this function here. dh. And then you have to follow through and actually work it out, which I don't really want to do. It's a little messy, but I'll just show you the solution so at least you know what to do. Yeah, that was also worth 3 points, as you can see. 1 point for the integrand. So boom, there. I actually think they should give me more points for the setup, to be honest with you. They pushed the 1/20th, they squares 140, 1/400. They push it off to the left. They foiled the 3 plus h squared, and then they actually did the antiderivative. So it was a point for that. So they give you a point for this, and a point for this, and then a point for actually working it out. But you could have left it like this, and even a-okay. But you gotta state the units though. You don't get the point if you don't have the so you've lost that point. So this is nice because it was a kind of a sneaky way of incorporating volume. The College Board may not just do a problem just dedicated towards volume, they might just sneak it into a problem. That was a really clever way of them doing that. The last one is going to be related rates. Shoot, it's not differential equations. That's okay. I was doing a DFQ problem. Well, I already kind of committed to this. So I'm just curious, what do I have DFQ then? Where was that? Maybe they didn't do it in 2016? I think I might remember. Oh, there you go. Okay, that's okay. That's fine. I want to review this stuff anyway with you guys. So here, it's a related rates problem. So they want to know at what rate is the height changing. Well, you already have this formula here, right? So just take the derivative both sides with respect to t. So dr of dt equals 1/20th. Actually, let me backtrack a little bit. Let me write this first. 3/20 plus h squared over 20. Let me do that first. That's easier. Then dr of dt equals 0 plus 2h over 20 times dh over dt. Okie dokie. Now we're in business. dr of dt you already know, and decreasing. So you want to say negative 1/5 equals, and 2h over 20 reduces to h over 10. And you want this at a height of 3, so you're going to say 3/10, right? Because that reduces to h over 10, so 3/10 times dh over dt. And then you just solve and state the units, please. There'll be negative 10 or 15 or negative 2/3 inches per second. And gotta give the units, right? Inches per second. And if I look at my answer key, yep, negative 2/3 inches per second. 2 points for actually the chain rule. So my guess is probably knowing to do this and knowing to do that. Probably those were the 2 points. Or maybe I think maybe that was a point and that was a point for substituting for dr dt, perhaps. I don't know how they exactly divide those points, but 1 point for the answer also. Okay, so well, I was really hoping to do a diffie Q, but that's okay. So let's do it for 2017. Well, let me just have you do number 4. It is a diffie Q, but you know it's good to do. 2017 is linear motion. 2016 is kind of a hodgepodge of different things. Number 6, 2017. But go and try number 4. I'll give you guys 15 minutes to do that. Then we'll talk about it at the end. And then maybe I can kind of briefly talk about maybe 2017 number 6, because that's kind of a nice hodgepodge of various topics. But 2017 number 4, they want you to write the equation of a tangent line. They do give you dh over dt. Read it kind of carefully. Part B, they want a second derivative, or they want to know, use the second derivative to determine if your estimate's under or overestimate. So it is kind of like a linearization type problem. And then C is solving a differential equation. So we'll do 2017 number 4. I'll stop the recording, and we'll check. And have questions, let me know. We'll check in at 9:45. See how it's going. We'll spend about 5 minutes talking about the solution. Then the last 10 minutes, I'll just kind of do 2017 number 6 with you guys, and then we'll wrap up the call. So pause. So resuming the recording, we'll go looking at 2017 number 4 from free response. So we have to write the line tangent to h at t equals 0. Remember, a line is just this, right? Y minus y1 equals m times x minus x1. At t equals 0 for h, well, obviously they give you the condition here, so y minus 91 equals m x minus 0. The slope is going to be your derivative, which is given right here, and they have it in terms of h. So actually, you're not going to plug in 0 for t, but when t is 0, the h value is 91. So you can do negative 1/4, a little tricky, but 91 minus 27, which I know is going to be 64, yeah. So you get negative 16. So y minus 91 equals negative 16 times x, or you can move the 91 over to the other side. And if you look how they divide those points, 1 point for the slope, which was negative 16, and of course 1 point for the actual, again, the tangent line, which we have right there. And actually, I didn't follow through on the rest of the problem. They want to find the internal temperature at 3, so plug in 3 for t or x, whatever, and you should get that answer as well. And state the units. Then they ask you to find the second derivative to see if it's under or overestimate. So this is about linearization. This is section 5.5, I believe. So when you have a curve and you have a tangent line, you use a tangent line to approximate. let's say, you know, this is A, right? This is x equals A, and you want to approximate something close to it. If your curve is concave up, which it looks like is this portion here, then the tangent line is going to under approximate. Where if it concave down, and I try to do an approximation, then I'm going to do over approximation when you're concave down. So if I do the second derivative of this, d2h over dt squared, or h double prime, it's going to be -1/4 times 1, because derivative of h minus 27 is 1, but then times dh dt, because it's implicit differentiation. So it's -1/4, and you bring the dh dt back into the mix, which of course is 1/16 times h minus 27. And they're telling us that we have to do this for terms greater than 27. So you know your d2h or dt squared is going to be positive, or you're concave up. Therefore, if you're concave up, your approximation will be an underestimate, because the tangent line is going to slightly go under the curve. And if you look at how they divide those points, really just 1 point for all that. So there you go. Then lastly, the differential equation. You want to separate the terms like we've done before. So I do dg, and I do g minus 27 raised to 2/3 down here. Over here I have -1 times dt, put a negative on that side. So this is the integral of g minus 27 actually raised to -2/3 dg. And of course I'm integrating negative dt. So that becomes negative t plus c. That's good. This over here, be a little careful, it's g minus 27. You have to add 1 to the exponent and divide by the new exponent. So it's 3 times the cube root of g minus 27 equals negative t plus c. So right off the bat, I'm getting a point for the separation, probably a point for each antiderivative. Okay, 1 point for the antiderivatives, because I guess the second one wasn't that hard. Then I have to substitute my initial condition, 0 and 91. So I plug in 91 for g. So I'm doing 3 times the cube root of 64, which I know is 3 times 4 or 12. On the other side, I plug in 0, so c equals 12. So I'm sure to give us a point for doing that. Yep, c is 12. And then I have to use it. So then I would say, okay, 3 times the cube root of g minus 27 equals negative t plus 12. Then I have to isolate g, which is going to be a little bit of work. I'll just show you the solution key at that point. So to give you another point for finding that equation, and then I guess you had to use it to plug in 3, right? You plug in 3 because they wanted the temperature there. So that's all for that one. Okay. So any questions about that? Okay, so lastly for number 6, we've just got a few minutes here. It's kind of a hodgepodge of various things they want you to do. For example, like they give you a table here, they give you a graph of h, they give you f, so they just kind of, I guess they probably just whip this together. But let g be the differential function, fine. The table in, let h be the graph, fine. So find the slope of the line tangent to the graph of f at x equals pi. I mean, you know how to do that, right? Let k be the function defined by this. So you're doing a composite function. So in this case, that's kind of a cool one. You have to do chain rule. Times f prime of x. So f of pi, you work that out. That's cosine 2 pi, which is 1. Sine pi is 0, e to 0. So I think that's 2. So h prime of 2 times f prime of 2. So I do also have to figure out what f prime is. And you just work that out. Yeah, you can see they have f of pi, f prime of pi is right and doing all that work. I guess we did had to find f prime for part A. So you could plug in pi into that and work that, you know, it's -1. And h prime of 2, just look at the graph. Yeah, it's definitely a slope of -1/3. So there you go. For C, that's going to be a product rule. So you have to do the product rule there, and of course use the table to help you with G over there in the graph for H. And then for D, is there a number C in a closed interval such that G prime C equals -4? I think that's going to be intermediate value theorem for derivatives. Or mean value theorem, never mind. Yeah, because I should have known better. Yeah, actually, you could actually get a slope of -4 when you focus on these points here. So if you find the average rate of change, it's going to be -4, and because it's differentiable, then you know that there's going to be a derivative that's going to equal that average rate of change. So that's mean value theorem. They kind of had a, you know, kind of snuck it in there. So that's kind of a hodgepodge of various topics. Yeah, again, I think they were just probably just maybe they were short on time. Who knows? But they seem like they whipped something together there. Who knows? I don't know what was the rationale for thinking of that problem. It kind of just seemed weird. I remember that year. Anyway, we're gonna end the call. You guys have been at this for since 8:30. So we go and stop the recording as well. So again, I am